My topic is about the binary number system, also known as the base 2 numeral system. Unlike the decimal system, which uses 10 different digits to represent values, the binary system only uses 2 digits, 0 and 1. Every digit in a binary number is referred to as a bit. In order to convert a decimal number into binary, first divide the number by 2. Keep track of the remainders, which would be either 1 or 0. Then use the quotient as the dividend and divide by 2 again. Repeat until the quotient is 0. After, write the remainders in reverse. For example, converting the number 5 into a binary number. First divide 5 by 2, which equals 2 remainder 1. Take the quotient, which is 2, and use it as your dividend. Divide 2 by 2, which equals 1 and 0 remainder. Use the quotient as your dividend again and divide by 2. So 1 divided by 2, and that equals 0 remainder 1. Now that the quotient equals 0, take the remainders from bottom to top, and that will be your binary number. Now, to convert a binary number to a decimal number, identify the place values from right to left. Each place value is a power of 2. The rightmost digit is 2 to the 0, and then move left and increase the power by 1 every time. So the next digit would be 2 to the 1. After this, multiply each binary digit by its corresponding place value and add them all up. For example, 1011 would be 1 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. Now, you may be wondering, why would someone make such a complex system, and where did binary numbers come from? Well, the modern-day binary system was created in 1703 by German polymath Gottfried Wilhelm Leibniz. He created it because he believed everything could be reduced to basic elements, but there are many instances of binary before him. In 2400 BC, the Egyptians used something called Horus I fractions, which was one of the 2 ways Egyptians used to represent fractions. The Horus I fractions are a binary numbering system which was used to count grains and measure liquids at the time. Around 1000 BCE, in ancient Chinese texts, the Yi Jing, or Book of Changes, was created. The Yi Jing used the binary concept, creating trigrams and hexagrams with either solid lines or split lines. A trigram is made up of 3 lines and a hexagram is made up of 2 trigrams. There were a total of 8 different combinations for trigrams and 64 different combinations for hexagrams, each representing forces in nature such as heaven, earth, water, and fire. Gottfried Wilhelm was interested in the Yi Jing and did some research on it. He was inspired by the solid and split lines, which today could correlate to the 1s and 0s he used for the binary system. In 200 BCE, Pingala, an Indian mathematician and poet, created a system very similar to the modern-day binary system. Pingala created this system to count the number of small syllables and long syllables in poetry. In his system, he used 0 to represent a short syllable and 1 to represent a long syllable. The difference between Pingala's system and the modern-day binary system is that Pingala's system started at the positional notation of 1 instead of 0. The positional notation in Pingala's system was used to order parts of a poetic meter, which is why it started at 1 instead of 0. Today, binary numbers are used within all computers and digital devices. The binary system is used to represent information to computers using bits, which is a single binary digit, hence why they are called digital devices. A bit has 2 possible states, 1 or 0. Bits can be combined to create larger units, such as bytes, megabytes, and so on, which we use to measure computer files. Everything in a computer is a collection of strings containing 0s and 1s, 0 meaning off and 1 meaning on. The reason we use the binary system is because if we were to add a different digit on top of 0 and 1, we would have to think about middle states like on a little bit or off a little bit. Binary can connect to Boolean logic, as Boolean also works on a system with an on and off. In Boolean, it's true or false.